Howdy folks, Mr. Reed here, and welcome to One More Question. So what we're going to be doing right now is taking a look at inverse relations. Specifically, I'm going to start with a function, and we are going to attempt to limit or restrict the domain of the original function so that we can make sure that the inverse is also a function. There are a few circumstances where this will come up where you'll want to make sure that the inverse of something is a function. So what we're going to do is we're just going to not really look for why we'd want to use it, but just be able to do it in the first place. So if you want to restrict domains to make sure you got a function for an inverse, let's get to it. All right, so we're going to take a parabola, pretty simple function. Very easy to see that it is a function, pass a vertical line test across it, and of course it is not going to cut through any of those x values, the y values for any particular x value, only going to be one per, and that wasn't said very well. But the idea is that you are not going to get a slice where you cut through two different y values for a single x. Now, that being said, if you were to do a horizontal line test, which is a way that we can test the inverse of the function that we're currently looking at, if we were to pass a horizontal line test across this thing, we would see that anywhere but where this thing isn't defined in terms of its range or the vertex, every other space is going to have two places where it gets cut. So this is going to brutally fail the horizontal line test, and therefore its inverse will not be a function. What we're going to do then is we're actually going to take this function and chop it up into bits that would pass the horizontal line test. So we can assure that at least for that domain, or that piece of the original function, that subset of a domain, we are going to be able to guarantee that the inverse will also be a function. So we could just be really, I don't know, it's kind of a cheesy way to do it, but you could take a very small subset. But we're going to try to make the largest subsets possible that are still going to give us that function for an inverse. So I just kind of put a couple dots there, one at 5 and one at 6 for the x values. Of course, that's going to pass horizontal line test. If we were to run horizontal lines across there, we would find out that those would all cut just once. But we can do better than that. We can actually take the vertex included, all of the values that are along the right-hand side of this parabola. We could also have taken the vertex included, all of the values that are instead along the left-hand side of this parabola. That was a really poor trace, but that's okay. So what I'm going to do is I'm going to actually state the domain that would correspond to those two slices, and then those are going to be our restricted domains. Now, this is fairly simple for a parabola. If this had been a situation where we had something that was a lot more up and down, we might have like 3, 4, 5, 6, or an infinite number of places where we would cut through if we were to do a horizontal line test, then we'd have to be a little bit fancier in terms of how we are going to pick things. But for us, it's going to be basically half the domain, and then vertex included on both of these. So option number 1 would be if we had our I probably should put D, our domain such a set of x's such that those x's are going to be less than or equal to the x value at the vertex, which is 3, and those x values are going to be elements of the real number system. So if we follow both those rules, that's going to properly describe the domain that goes along with the, I guess, the yellow trace that I had made. If we are to pick the other one instead, those domain values would be x's such that the x's are larger than or larger than or equal to 3, as well as being an element of the real number system. If we follow both those rules, that's going to properly describe the subset of the original domain that would go with the right-hand branch of this parabola. Now, that's all we really need to do, because either one of those options is going to pass the horizontal line test, which means that the inverse is going to pass the vertical line test, or another way to say that is it will be a function. Just to talk about which part corresponds to which part of the new function, So if we did the entire inverse relation, we're going to have a sideways parabola. I don't know if it's going to face that way or that way. I'm not very good at this mirrored thing. So we'd have a sideways facing parabola one way or the other. So if I did it properly, it kind of exists way over here and goes something like this. Now, I'm going to erase that in just a sec, but that's kind of the idea behind it. That's going to have a top half and a bottom half, one that corresponds to domain 1 and one that corresponds to domain 2. So the question is, how can we know which one is which? Well, that's actually really easy, because what we're doing here is basically swapping our x for our y when we do the inverse. So if our domain was originally all the values less than or equal to positive 3, that means the range of the inverse function is going to be all the values that are less than or equal to positive 3. So that's going to be the underside of the sideways facing one. If we were to choose instead the second option, which are all the values that are greater than or equal to 3, those are the top or the positive side of the domain. It's going to be the top or positive side of the inverse's range. So we can tell which part of the inverse we're going to get as well, that it's going to be a function, because the piece that we originally have passes the horizontal line test on the first function that we're looking at. All right, folks, so if you found that one helpful, like, subscribe, and as always, take care.